I have spent my entire career answering questions. That's what physicists do. We take mysteries and we turn them into equations. We take confusion and we turn it into clarity. We have explained how stars burn, how atoms hold together, how light bends around massive objects, how the universe expanded from a hot, dense state into the vast cosmic web we see today. We have been spectacularly successful. But there are questions we cannot answer. Not yet. Maybe not ever. I'm not talking about questions we haven't gotten around to yet, or questions that need better equipment, or questions waiting for a smarter generation of physicists. I'm talking about questions that might be fundamentally outside the reach of physics. Questions where the scientific method itself hits a wall. Questions that make us wonder whether physics has limits, boundaries beyond which it cannot see. These questions haunt me. They haunt every honest physicist who thinks deeply about the foundations of our discipline. We don't talk about them much in public because science is supposed to project confidence. We're supposed to say that everything is solvable, that it's only a matter of time, that the final theory is just around the corner. But that's not true. Some questions might not have scientific answers. Some mysteries might be permanent, and I think you deserve to know what they are. Here are 7 questions that physics, despite all its power and precision, cannot answer. Number 7. Why is there something rather than nothing? This is the oldest question in philosophy, and physics has not made it go away. If anything, physics has made it worse. Think about it. Why does anything exist at all? Why is there a universe? Why is there matter, energy, space, time? Why isn't there just nothing? Absolute nothing. No space, no time, no laws of physics, no quantum vacuum, no potential for anything, just pure, absolute, metaphysical emptiness. Nothing seems simpler than something. Nothing requires no explanation. Nothing has no properties that need accounting for. If you are betting on what exists, nothing seems like the safer bet. And yet, here we are. Something exists, a lot of something, an entire universe of something. Physicists sometimes claim to have answered this question. Lawrence Krauss wrote a book called A Universe from Nothing, arguing that quantum mechanics allows the universe to pop into existence spontaneously from a quantum vacuum. The vacuum is unstable. Fluctuations happen, universes emerge. But this doesn't actually answer the question. It just pushes it back one step. The quantum vacuum is not nothing. It's something. It has properties. It obeys laws. It contains fields with specific characteristics. Asking why there's a quantum vacuum rather than absolute nothing is just as hard as asking why there's a universe. The same problem afflicts every physical explanation. You might say the universe exists because of the Big Bang. But what caused the Big Bang? You might say the Big Bang was a quantum fluctuation in a pre-existing state. But why did that state exist? You might say that state is eternal and self-causing. But why does anything have the property of being eternal and self-causing? Every answer requires something to already exist. Every explanation presupposes existence. Physics cannot pull existence out of non-existence because physics itself is part of existence. The laws of physics are something, not nothing. They can't explain why there are laws rather than no laws. Some philosophers argue that this question is meaningless, that asking why there's something rather than nothing is like asking what's north of the North Pole. But I don't find that convincing. The question feels meaningful. It feels like the deepest question there is. And the fact that we can't answer it, that every attempt at an answer presupposes what it's trying to explain, suggests that we've hit a wall. Physics can describe what exists. It can explain how things change over time. But it cannot explain why anything exists in the first place. That question lies outside its reach. The universe obeys specific laws. The gravitational constant has a specific value. The speed of light has a specific value. The mass of the electron, the strength of the strong nuclear force, the number of spatial dimensions. All of these could have been different. There's no logical necessity that forces them to be what they are. So why these laws? Why these constants? Why this universe rather than some other universe with different rules? This question has become especially urgent since we discovered how finely tuned the constants appear to be. If the gravitational constant were slightly stronger, stars would burn too fast for life to evolve. If the strong nuclear force were slightly weaker, atoms heavier than hydrogen couldn't form. If the cosmological constant were much larger, the universe would have expanded too quickly for galaxies to coalesce. The constants seem to sit in a narrow window that allows complexity, allows chemistry, allows life. Change them a little and you get a sterile universe of nothing but radiation, or black holes, or diffuse gas that never clumps into anything interesting. Why are we so lucky? Some physicists invoke the anthropic principle. They say we observe these constants because only these constants allow observers to exist. If the constants were different, we wouldn't be here to ask the question. This might seem like an explanation, but it's not. It's a selection effect, not a cause. It tells us why we observe what we observe, but not why the thing we observe exists in the first place. The multiverse hypothesis is another attempt. Maybe there are infinitely many universes with different constants, and we happen to be in one that supports life. But this just pushes the question back. Why is there a multiverse? Why does it generate all possible constants? What determines the probability distribution over possible universes? The deeper problem is that physics describes laws but cannot explain them. Physics tells us what the laws are and how they operate. It doesn't tell us why those laws exist or why they have the form they do. The laws of physics are taken as given, as the starting point of explanation. But where did they come from? Some physicists hope that a final theory will show that the laws couldn't have been otherwise, that there's only one mathematically consistent set of laws, and that's what we observe. But even if this were true, it would just raise another question. Why does mathematical consistency have the power to bring universes into existence? Why does logical necessity translate into physical reality? Physics explains things in terms of laws. It cannot explain the laws themselves. At some point we hit bedrock. The laws just are what they are, and physics has to accept them without explanation. We all know what time is. It's what clocks measure. It's the dimension we move through from past to future. It's the thing that keeps everything from happening at once, except we don't actually know what time is at all. Physics uses time constantly. Every equation, every prediction, every measurement involves time. But physics doesn't tell us what time actually is. It treats time as a parameter, a variable, a coordinate. It describes how things change with respect to time, but it never explains what time itself is. Consider the difference between time and space. In relativity, they're unified into space-time, treated almost symmetrically, yet they feel completely different. You can move freely in space, forward and backward, left and right. You cannot move freely in time. You're carried along in one direction only from past to future, with no ability to stop or reverse. Why? What makes time different from space? Physics doesn't say. The equations of physics are mostly time-symmetric. They work just as well running backward as running forward. If you film a simple physical process and play the film in reverse, the physics still makes sense. Balls unbouncing, pendulums unswinging, all perfectly legal according to Newton's laws. Yet we never see this happen. We never see eggs unscramble or coffee unmix. Time has a direction, an arrow that the fundamental laws don't seem to explain. Physicists usually attribute the arrow of time to entropy, the second law of thermodynamics. Entropy increases, disorder grows. That's why the past looks different from the future. But this just pushes the question back. Why was entropy low in the past? Why did the universe start in such an ordered state? And more fundamentally, why does increasing entropy create the experience of time flowing? The experience of time flowing is itself a mystery. Physics describes a block universe where past, present, and future all exist equally. There is no special now moving through time. Yet we experience a present moment. We feel time passing. We have memories of the past but not the future. What creates this experience? Physics doesn't say. The block universe is static. Nothing moves through it. Yet we feel like we're moving through it. This disconnect between the physics and the experience is unexplained. Maybe time is fundamental. Maybe it's emergent. Maybe it's an illusion. Maybe it's something physics will eventually explain. Or maybe it's something physics can't explain because physics takes place within time and cannot step outside it to examine it objectively. We don't know. After centuries of physics, we still don't know what time is. Number 4. Why does mathematics describe reality? Here is something that should bother you. Mathematics, an abstract human invention, describes the physical universe with extraordinary precision. Think about how strange this is. Mathematics is the study of abstract structures, numbers, shapes, functions, equations. These are mental objects. They exist in the realm of pure thought. A mathematician can explore mathematical truths without ever looking at the physical world. Mathematics seems to be about ideas, not things. Yet physics uses mathematics to describe reality, and not just approximately. Exactly. The predictions of quantum electrodynamics match experiments to 11 decimal places. General relativity predicts gravitational effects with stunning accuracy. The mathematical laws of physics don't just work. They work perfectly. Why should abstract mental objects map so precisely onto physical reality? Why should the universe be mathematically structured at all? Eugene Wigner, a Nobel Prize-winning physicist, called this the unreasonable effectiveness of mathematics. He wrote a famous essay about it in 1960, and we still don't have a good answer. Consider some examples. Complex numbers were invented in the 16th century to solve abstract algebraic equations. They seemed like mere mathematical curiosities, tricks for dealing with the square roots of negative numbers. 300 years later, quantum mechanics arrived, and it turned out that complex numbers are essential for describing the quantum world. The wave function is inherently complex-valued. Nature was waiting for us to invent the right mathematics. Non-Euclidean geometry was developed in the 19th century as a pure mathematical exercise. What if parallel lines could meet? What if space could be curved? It seemed like an intellectual game with no practical application. Then Einstein showed that space really is curved. Non-Euclidean geometry describes gravity. The abstract mathematics turned out to be physical reality. This keeps happening. Mathematicians invent structures for purely theoretical reasons, and physicists later discover that those structures describe nature. It's as if the universe is made of mathematics, or as if mathematics gives us access to a deeper level of reality than our senses can reach. But why? Physics can't answer this. Physics uses mathematics. It doesn't explain why mathematics works. It doesn't explain why the universe is comprehensible. It doesn't explain why abstract human reasoning can unlock the secrets of nature. Some physicists, like Max Tegmark, argue that the universe literally is a mathematical structure, that physical existence and mathematical existence are the same thing. But this is metaphysics, not physics. It can't be tested. It's a philosophical position dressed up in scientific language. The effectiveness of mathematics remains unexplained. It's a gift we've received without understanding why. And every time we use an equation to predict an experiment, we're relying on a mystery we haven't solved. You are aware. You have experiences. There is something it is like to be you. Sensations of light and color, the feel of comprehension or confusion, a sense of being present, of existing, of being here. This is consciousness, and physics cannot explain it. The problem isn't that we don't understand the brain. We understand a lot about the brain. We know which regions handle vision, language, memory, emotion. We can trace neural pathways, measure electrical signals, image brain activity in real time. Neuroscience has made enormous progress. But none of this explains why there's subjective experience. You can describe all the physical processes in the brain, all the neurons firing, all the chemicals flowing, and you still haven't explained why those processes feel like anything from the inside. This is what philosopher David Chalmers calls the hard problem of consciousness. The easy problems are explaining functions. How does the brain process visual information? How does it store memories? How does it generate behavior? These are hard in practice but tractable in principle. We know what an answer would look like. The hard problem is different. It asks why physical processes are accompanied by subjective experience at all. Why isn't the brain just a machine that processes information in the dark, with no inner light, no feeling, no awareness? Why is there a what it's like to be a brain? Physics describes objective properties: mass, charge, spin, position, momentum. These are properties that can be measured from outside. But consciousness is inherently subjective. It's known from inside. It's what it's like to be something, not what it looks like from outside. Some physicists and philosophers think consciousness will eventually be explained by physics, that once we understand the brain well enough, the feeling of awareness will turn out to be a physical process like any other. But others think there's a fundamental gap, that subjective experience cannot be reduced to objective description, that you could know everything about the physics of a brain and still not know what it feels like to be that brain. I don't know who's right, but I know that physics, as currently practiced, has no theory of consciousness. It's not even clear what a physical theory of consciousness would look like. Consciousness might be emergent, arising from complex information processing. It might be fundamental, built into the fabric of reality like mass or charge. It might be something we can't even imagine yet. What I can tell you is that physics describes a universe of particles and fields and forces, and somewhere in that universe, there's awareness, there's experience, there's you reading this, feeling something, and we don't know how that's possible. You made a choice to read this. At least you think you did. You could have done something else. You could have stopped reading at any point. The decision was yours, or was it? Physics describes a universe governed by laws. In classical physics, those laws are deterministic. Given the exact state of the universe at one moment, the laws determine its state at every future moment. The future is fixed by the past. Every event is caused by prior events, stretching back to the beginning of time. If your brain is a physical system, and physical systems are deterministic, then your choices are determined. They're the inevitable result of prior causes. The feeling that you could have chosen differently is an illusion. You were always going to choose what you chose, because the laws of physics made it so. Quantum mechanics complicates this picture. At the quantum level, events are not deterministic, they're probabilistic. The decay of a radioactive atom, the path of a photon through a beam splitter. These are genuinely random according to quantum mechanics. They're not determined by prior causes. Does this help free will? Probably not. Randomness isn't freedom. If your choices are random rather than determined, that doesn't make them free. It makes them arbitrary. You're not choosing if a quantum coin flip is making decisions for you. So physics seems to leave no room for free will. Either your choices are determined by prior causes, or they're random, or some combination. Neither option sounds like genuine freedom, the ability to have done otherwise, the authorship of your own decisions. Some philosophers argue that free will is compatible with determinism. They define free will as acting according to your desires without external constraint. By this definition, you can be free even if your desires are determined. You're free because nothing is stopping you from doing what you want, even if what you want is the inevitable product of physics. Others reject this as a hollow redefinition. They say genuine free will requires the ability to have done otherwise, to be the ultimate source of your choices. And physics doesn't allow for that. I don't know the answer. I don't know if free will is real or an illusion, but I know that physics doesn't settle the question. Physics describes the behavior of physical systems. It doesn't tell us whether we're more than physical systems, or whether physical systems can have genuine freedom. The feeling of choosing is overwhelming. It's central to our lives, our relationships, our society, our morality. And physics has nothing to say about whether that feeling corresponds to reality. You made a choice to watch this. At least you think you did. You could have done something else. You could have scrolled away at any point. The decision was yours. Or was it? Physics describes a universe governed by laws. In classical physics, those laws are deterministic. If you know the exact state of the universe at one moment, the laws determine its state at every future moment. The future is fixed by the past. Every event is caused by prior events, stretching all the way back to the beginning of time. If your brain is just a physical system, then your choices are determined too. They're the inevitable result of prior causes. The feeling that you could have chosen differently is an illusion. You were always going to choose what you chose. But then quantum mechanics enters the picture. At the quantum level, events aren't deterministic. They're probabilistic. Think about it. The decay of an atom is genuinely random. It's not determined by prior causes. So does this randomness make room for free will? Or is it just another way we're not in control? Thanks for watching. Does this help free will? Probably not. Randomness isn't freedom. If your choices are random rather than determined, that doesn't make them free. It makes them arbitrary. You're not choosing if a quantum coin flip is making decisions for you. So physics seems to leave no room for free will. Either your choices are determined by prior causes, or they're random, or some combination. Neither option sounds like genuine freedom, the ability to have done otherwise, the authorship of your own decisions. Some philosophers argue that free will is compatible with determinism. They define free will as acting according to your desires without external constraint. By this definition, you can be free even if your desires are determined. You're free because nothing is stopping you from doing what you want, even if what you want is the inevitable product of physics. Others reject this as a hollow redefinition. They say genuine free will requires the ability to have done otherwise, to be the ultimate source of your choices. And physics doesn't allow for that. I don't know the answer. I don't know if free will is real or an illusion, but I know that physics doesn't settle the question. Physics describes the behavior of physical systems. It doesn't tell us whether we're more than physical systems or whether physical systems can have genuine freedom. The feeling of choosing is overwhelming. It's central to our lives, our relationships, our society, our morality. And physics has nothing to say about whether that feeling corresponds to reality. Number one, why are we here to ask these questions? This is the deepest question of all. Not just why does the universe exist, but why does it contain beings who ask why it exists? Consider the improbability of our situation. The universe began as a hot, uniform plasma. Over billions of years, it cooled and clumped into galaxies, stars, and planets. On at least one planet, chemistry became biology. Simple life became complex life. Complex life became intelligent life. Intelligent life developed language, science, and philosophy. And now here we are, asking questions about the nature of reality. Why? Physics can describe the process. It can explain how gravity pulls matter together, how nuclear fusion powers stars, how supernovae spread heavy elements through space, how those elements form planets with liquid water, how chemistry on such planets might generate self-replicating molecules. It can tell a story of cosmic evolution from the Big Bang to the present moment. But it can't explain why this story leads to beings who understand it. There's no law of physics that requires intelligence to emerge. There's no equation that predicts consciousness. The universe could have been sterile, a vast expanse of gas and rocks and radiation with no one to observe it. That would have been just as consistent with the laws of physics as what we actually observe. Some scientists invoke the anthropic principle again. We observe a universe that produces observers because only such a universe would be observed. But this feels like a tautology, not an explanation. Yes, we had to be in a universe compatible with our existence. But why does such a universe exist? Why is the universe set up in a way that allows for minds? Some think the answer is design, that an intelligence created the universe with us in mind. This is a religious answer, not a scientific one. It might be true, but physics can't evaluate it. Physics can't tell us whether the universe was designed. Others think the answer is chance, that we're a cosmic accident, an unlikely outcome in a vast multiverse of possibilities. This might also be true, but it's not an explanation. It's an admission that there is no explanation. And some think the question itself is confused, that asking why we're here assumes a purpose where there is none. The universe doesn't have reasons, it just is. I find all these answers unsatisfying. I don't know why we're here. I don't know why the universe produced minds that can contemplate it. I don't know why there's understanding, why there's meaning, why there's us. Physics has given us extraordinary knowledge. It has revealed the age of the universe, the structure of matter, the evolution of stars, the nature of space and time. But it hasn't told us why any of this leads to a being who can know these things. We are the universe looking at itself. We are matter that has become conscious of matter. We are the cosmos asking what the cosmos is, and we don't know why. I've spent my life at the frontier of knowledge, pushing against the boundaries of what can be known. I've seen those boundaries expand enormously. Questions that seemed permanently mysterious have yielded to careful experiment and mathematical analysis. Physics has been astonishingly successful, but the questions I've shared with you tonight are different. They're not waiting for better technology or smarter physicists. They might be fundamentally unanswerable by the methods of science. Why does anything exist? Why these laws? What is time? Why does mathematics work? What is consciousness? Do we have free will? Why are we here? These questions sit at the edge of physics, where science meets philosophy, where knowledge meets mystery. They're the questions that keep me up at night. They're the questions that remind me how much we don't know. Some of my colleagues think these questions will eventually be answered, that physics will continue to expand until nothing remains unexplained. I used to think that too. Now I'm not so sure. Maybe some mysteries are permanent. Maybe some questions are beyond the reach of any possible science. Maybe the universe contains depths that no equation can plumb. I don't say this to discourage you. I say it to be honest. Science is powerful but not omnipotent. It illuminates but doesn't illuminate everything. The night sky is full of light, but it's also full of darkness. And some of that darkness might be permanent. What do we do with questions that can't be answered? I think we hold them. We sit with them. We let them humble us. We let them remind us that we're finite creatures trying to understand an infinite cosmos. The questions we cannot answer are just as important as the questions we can. They define the horizon of our knowledge. They show us where we stand in relation to the unknown. And they remind us that the universe is not obligated to be fully comprehensible to beings who evolved on a small planet orbiting an ordinary star in the suburbs of an unremarkable galaxy. We've done remarkably well, given our limitations. We've understood far more than we had any right to expect. But we haven't understood everything, and we may never. These 7 questions are my gift to you, not answers. Questions, the kind of questions that expand your mind just by asking them. The kind of questions that remind you how strange and deep and mysterious reality truly is. Hold them carefully. They're precious. They're the edges of the map, where the known world ends and the unknown begins. And beyond those edges, there's only wonder.